Okay, so in this video, we're going to talk about our model that we now use, which is called the quantum model. And there were several different people that contributed to the quantum model. Schrodinger, Heisenberg, de Broglie, Einstein, Hahn. There was, like I said, a lot of them. But basically, the part that I want you to remember is that in the quantum model, we now know that the electrons are considered to be acting as waves and or particles. And according to which one we're looking at is what we're trying to find. So if we're considering them as waves, then we're looking at maybe the frequency, the mass, or the velocity of them. And if we're at particles, then what we're looking at is trying to figure out the location of them and or the velocity at which they're traveling. So that is the model that we're using today, along with all of the rest of the stuff that we now know to be true. So the first thing that we're going to look at is the parts of the quantum model. So our first question says is, what are the two regions that we now have? And they are the nucleus and the electron cloud. So I'll read through this real quick, and then I would suggest that you pause and write this down. So first off, for the nucleus, we know that it contains the protons and the neutrons. We know that it contains a hard, dense core, because that is what the nucleus is, that hard, dense core, very small. We know that 99% of the mass is contained within the nucleus, again, because it is a very hard, dense core. We also know that the nucleus is positive in charge. That comes back up through here because it contains protons and neutrons, okay? And the protons are positive. So if you only have positives and zero, then you're going to be positive in charge, okay? So that is your nucleus. The second one is the electron cloud, and we know that the electron cloud now contains negatives. We do know that they are in specific energy levels. We do know that the electron cloud consists of empty space. We also know that it is negative in charge because all it contains is electrons. And the other thing is that it contains most of the volume in the nucleus. Now, one thing you have to realize when we talk about those two regions, you've got your nucleus, which is positive. You've got your electron cloud, which is negative. And so since those are equal in value, we'll talk about equals electrons in a little bit, because those are equal in value, then we do know that the atom overall has a neutral charge. So anytime we talk about the atom, it has to have a neutral charge. The positives have to equal the negatives. So I would pause if you have not, and be sure you have that recorded. Okay, so the next three things that we're going to talk about are the three subatomic particles. And we've already found them in our chart, but let's talk about them again in case you don't have stuff written down. We know that the proton is positive in charge. It has almost the same mass as the neutron, although the neutron is slightly larger. Okay, so it's considered the largest by mass of the subatomic particles. Okay, so very similar in size, although the neutron is slightly larger. Remember, the neutron has no charge. You have the electron, again, that is negative in charge. And the way they describe it is that it's about 2,000 times lighter than the proton, or the proton weighs 2,000 times more than the electron. Again, I would pause and be sure you have that recorded. Okay, so the next question that we're going to have is, what is the forces that are acting in the nucleus? Now, we're not going to get into in-depth discussion on it, but there's three forces that are acting. There is the strong nuclear, the weak nuclear, and the electromagnetic. Now, we've kind of talked about the electromagnetic a little bit already, because we talked about how that a positive and a negative will attract, where two negatives repel, two positives repel. So that's kind of what we're talking about here. And so that's very normal. Everybody knows that. We've seen magnets before. But when we talk about why do we need a strong nuclear force or a weak nuclear force in the nucleus, okay, or in the atom? And so let me just come over here and talk about, if you think about the nucleus, and what I told you was the nucleus contained a bunch of protons and neutrons, right? But go back to what we talked about, that if you have positive and positive in charge, they're going to want to automatically repel. So the question is what keeps then that nucleus from just exploding? Okay, what keeps those protons from just shoving each other out of the way and getting them? So that's where you have to have your strong nuclear charge. So that strong nuclear charge is kind of pulling them together. Somebody in class mentioned the fact that magnets, if you have two positive magnets and you try to push them together, okay, you can push them together, but they are going to push against you. You can kind of feel that. And that's kind of what's going on here. So we're taking those positives and we're forcing them to stay somewhat close together in that nucleus, okay? Now, in the same way, we have electrons that are running around out here in the electron cloud. So the question is, what keeps that electron, because we know positives and negative attract, what's keeping that electron from then going into the nucleus if, in fact, it has a negative and these have a positive? Why isn't it just attacking this and wanting in really, really bad? And again, this is where we have that weak nuclear charge that's coming in there. So even though we're saying, yes, we're attracted to those positives, there's also a force that's kind of keeping them in their orbital out there in the cloud and not going inside the nucleus. So we're not going to get into tons of stuff, but definitely you kind of have to have a kind of a feeling of that. If you look in your textbook over this, what normally happens is on a normal high school textbook, you might have about a paragraph over this, so that we don't get really in depth into it. If you want to get more into the different forces, then we need to go into honors and AP. Okay, let's go on to the next one. Okay, and the next question says, how does the size of the two regions compare? So we're talking about the size of the, okay, sorry about lost my train of, somebody interrupted. How does the size of the two regions compare? And so here is a very good visual of what this would look like. Remember, we said that most of the electron cloud is empty space. So if you can envision this amount of the size, this, not necessarily size, what I want to say is the correlation between these two things. And that would be as if you had a baseball put in the center of a football field. Okay, that would be that relationship there is between the nucleus and the electron cloud. Okay, so that's how much bigger that electron cloud would be to the nucleus. So again, most of the volume of the electron is in the electron cloud. That's all this space out here. Most of it is empty space, but it is out there where these, think of maybe if you had a baseball in the middle and you had a few little kids running around outside here, they've got the whole freedom of this football field to run around in. Okay, so that's what we're talking about, just to give you a visual of it. Okay, then the next part, and we've already did some of these in our tables, but this is should just be a review. How do you find the number of subatomic particles? So when I go to find the protons, remember that is just your atomic number. If you want to, you can always draw that in here. Here's a picture of my box. Here's hydrogen. And remember, your atomic number is going to be up at the top. Now, sometimes it's over to the right, sometimes it's to the left, sometimes it's to the center, according to which periodic table you have. But again, it is still going to be at the top up here. Okay. Then you have your number of electrons. Remember, we said the atom was neutral. So therefore, the number of electrons has to equal the number of protons. Okay. So that number is also going to be the number of electrons. The one that's harder to find is the number of neutrons. Okay. So first off, if you have hydrogen, okay, this number here, okay, let's not confuse them, is called the atomic mass, okay, atomic mass. And it is always going to be a decimal value, okay, atomic mass. And we're going to talk more about how to compute that later on. So this number is the atomic mass, okay. So what you need is what is called the mass number, okay. And we take the atomic mass and we round it. So in this case, it would be 1, okay. So for hydrogen, your mass number is 1. So we would take 1 minus the number of protons. So in this case, 1 minus 1 is 0. So there's 0 neutrons in this regular hydrogen atom. Okay? So we're going to stop there. Be sure you have all of your notes filled out. Go back in and fill them out as needed.